All right, so now we are going to do a question on acceleration. All right, so the first thing we need to know is to, and let me read the question first. As usual, a baseball player moves in a straight line path in order to catch a fly ball hit to the outfield. His velocity of time is shown in figure 2.11 here, which is this figure you are seeing there. Okay, find his instantaneous acceleration at points A, B, and C. Alright, so first of all, as usual, you need to understand what acceleration is. Okay? Alright, so an acceleration, if this is the rate of change. This is rate of change of displacement, I mean of velocity over time. Okay, so acceleration is given by velocity over time. Okay, so now what you need to know that acceleration, velocity, and displacement, all these are vector quantities. So when an object is moving, we have a car here. Okay, let's say this car is moving in the positive x direction. The acceleration is going to be positive. Now if it changes direction, it starts moving in the negative x direction, okay, the acceleration is going to be negative. This same applies to velocity. Okay, this same applies to velocity and displacement, which I've just explained earlier. All right, so now what about the average velocity? What does it mean when you say the average velocity? The average velocity now, it's going to be, I mean, my the average acceleration. Average velocity is still sticking in my mind. So the average acceleration now is going to be given by the change in velocity over the change in time, where the change in velocity are going to have v final minus v initial. Okay, then t final minus t initial. From this time now you understand what this formula actually mean. Okay, so with this information you can now go ahead and understand what an instantaneous acceleration means. Just as we were talking about the instantaneous velocity, an instantaneous acceleration, this is the acceleration at a certain point in motion. For example, I've been asked to say that find the acceleration at t is equal to 1. Just to know that they're asking at the instantaneous acceleration, which is just going to use the what? We're going to use the gradient. We're going to have our v final minus v initial over t final minus t initial using the same point. That's why I used to say that the formula are one and the same. What is going to differ is the approach. Okay, so to understand more, that's why I like explaining with an example. There we use a question. So this is the question now. A base player moves in a straight line path in order to cut a fly ball hit to the outfield. His velocity as a function of time is shown in figure 2.11a. Find his instantaneous acceleration at point A, B, and C. Alright, so what we are going to do, guys, we already know that at point A here, this is the point A in motion. What if I choose bro? Is there any problem? Oh, no problem. Alright, so at point A, we are going to find the instantaneous acceleration. Okay, the instantaneous acceleration at point A, we already know the formula. So what we are going to do, we are going to take 2 points. Okay, we are going to take 2 points. The first point, we know that this line is running from here. Point acceleration, we take the phase. Okay, the first phase for A is running from here all the way to here. So we can take 2 points. The first point is here, and this point is at 0, 0. And this point, as you can see, it is at 2 comma 4 here. Okay, it is at 2 comma 4. We start from the x-axis. This one is for t initial and this one is for t final. We have our x initial and our x final. So the instantaneous acceleration there is going to be our x final minus x initial over our t final minus t initial. Okay, well, our x final is actually 4, our x initial is 0, where our t final is actually 2, our t initial is 0. This means to say we are having 4 minus 4 over 2. Even without using a calculator, we can find to be of 2 meter per second square there. You get that? So now we can go and find the instantaneous acceleration at point B. So point B is running from this point up to this point. We can take the points there. Okay, we can take the points. As you can see here, so meaning it is also ending at this point. So we have T1 to be 2 and T initial to be 2 and T final to be 3. So we get to say our T initial to be 2 and our T final to be 3. Okay, now we can go and determine the value of displacement of velocity there. As you can see, the line is straight. For an acceleration for a velocity time graph, when you see a line is a straight line, it means velocity is constant. Take note of this point. And when velocity is constant, acceleration is 0. You are going to understand this. When you hear that velocity is constant, it means velocity is not changing. So as you can see, the first point, velocity is 4. So our V1, our V initial is actually 4 meter per second. My apologies here. Instead of using X, it is V. But the calculation are just one and the same. I don't know why I'm getting back to what we were doing in the previous video. Okay, so I'm going to take a list maybe. All right, so now what you do here, this is our V1. Our V initial, we run from here to where our graph is ending at 4. Even at T3 is at this point. When you go to the left, we also get 4 here. So even we'll get our V final to be 4 meter per second. What does it mean? 4 even mean that this driver maintained the speed. Okay, maintain the speed. The speed is not changing of this car. Okay, so when the speed of the car is not changing, we call the V is constant. Okay, and when the V is constant, the acceleration is always going to be 0. Understand this, guys. On the graph of a velocity time graph, you're going to see something which will be looking like a straight line. Okay, when you see a line is moving like this, it means it is accelerating. It is accelerating. Now if a graph is now moving like this down, that is decelerating, negative acceleration. This is decelerating. All right, so now we can find the instantaneous acceleration to be our V final minus V initial is equal to our T final minus T initial. Okay, so our acceleration, our V final is 4, our V initial is also 4. So our T final is 3, our T initial is 2, where we get 0 over 1, which is actually 0 meter per second square. That's why I was saying that when velocity is constant, the acceleration is going to be 0. and this has been proven, as you can see. Okay, we can go and do now we can find the acceleration, the instantaneous acceleration at point C. As you can see now, point C, this is what I'm talking about. The graph is going downward. So we should expect to have a negative acceleration because this is deceleration. It's different from point A where it was accelerating. So we are going to take also 2 points. Okay, the first point, it is, as we can see, this line is starting from here all the way to here. So our T1, our T initial is going to be 3 and our T final is going to be 4. So we get here, we say our T initial is going to be 3 and our T final is going to be 4 seconds there. What about our V final? Okay, so our V initial is at T initial, which is at T3. And we can see that this is actually 4. Okay, it is actually 4. So our V initial is 4 meter per second. What about our V final? We go to the graph. The graph is ending here. So our V final now is at, when we go here, we are getting it at 2 there. Okay, we have 2 meter per second. All right. So how do we get now? We get back to the formula. Acceleration is going to be V final minus V initial is going to be T final minus T initial. Okay, the acceleration is going to be our V final is 2 and our V initial is 4. What about our T final is 3? Our T initial is actually 2. So we're going to have our acceleration to be there on top we have negative 2. Down here we have 1, which our acceleration is going to be negative 2. And this makes more sense because when the line is dropping there, the graph is dropping, just know that the acceleration is always going to be negative. So this is, guys, what you need to understand about the acceleration. So thank you for watching. We are going to continue now doing acceleration, motion when the acceleration is constant. We're going to understand about those 3 formulas which you need to know, the equations of motions which you need to know. It are very important. So thank you for watching. See you in the next video. For you haven't subscribe to the channel now. You like the video, also hit the notification button so that you may not miss out on your uploaded videos.